All right, so we're going to continue. We're going to rationalize each denominator. Again, this won't reduce. This is outside and that's inside, so I can't mix those two. But I do have a radical in the denominator that I need to make perfect. It is, I have to look at the index and I see that it's a fourth root. So here at the bottom, I've written the perfect fourth powers. 2 to the fourth is 16, 3 to the fourth is 81. X, any variable with a 4 number that 4 will go into evenly, so like x to the fourth, a to the fourth, x to the 8th, or x to the 12th. Those would be fine as well. All right, so I see that I've got a 2, so I'm going to want 2 to the fourth, which is 16. And to get a 16, then I would need to multiply this by 8. So whatever I do to the denominator, I have to do the same thing to the numerator. And I then get 6, fourth root of 8, divided by, and then this is going to be the fourth root of 16. And the fourth root of 16 is 2. So then this is 6, fourth root of 8. This will reduce right there, and I'm going to end up with 3, fourth root of 8 for my final answer. All right, so then going down to C, I have a fraction. It does not reduce, and it's a cube root, so I can't take the cube root of 9. I need to have a perfect third power, and so something that I can change, multiply and get a 9 out of, so that's going to be 27. So I am going to multiply this by 3, so that when I finish multiplying, I'm going to end up with a cube root of 27. Whatever I do to the denominator, I have to multiply the numerator by the same thing, so that I've got this clever one right there. And this time they're both inside, so I'm going to get the cube root of 6. I don't know the cube root of 6, but the cube root of 27 is 3, and that is my answer. All right, so I'd like for you to stop the video now and try examples D and E. And remember, I said try. I'd like you to give them a try and see what questions you have as you try it. So we'll do those, and then we'll talk about them in class. And then in class, we'll finish up with E and F. All right, so to repeat, when we have a fraction with radicals, we'll first try to reduce the fraction. We'll next check to see if we can simplify the radicals, and then we'll check the denominator to see if it needs to be rationalized. All right, so here, nothing reduces, but I do know what the cube root of 8 is. The cube root of 8 is 2, and the cube root of x to the fourth would give me an x, cube root of x. 3 will go into 4 once, perfect, 1 left over. And then I'm left down here with the cube root of 9. So when we talk about perfect third powers, I can change that 9. One of them is going to be 27. So I'd like to change that 9 into 27. So I'm going to multiply it by the cube root of 3. So whatever I do with the denominator, I'll do the same thing with the numerator here. And I'll come up with then cube root of 27, which is 3. And then in the numerator, I have a 2x, and then I have the cube root times the cube root, and it's 3 and x. So I'll write that here again. That's 2x outside, cube root of 3x. This does not reduce because one of them's outside and one of them's inside. All right, so h, again, the fraction does not reduce, but I can simplify the square root of x squared to x. And then the square root of y to the fifth, so 2, this remember understood 2 here. 2 will go to 5 2 times, so that gives me a y squared with 1 left over. All right, so now I've done my 2 steps, and I'm left with a radical in the denominator, which I need to rationalize. So it's a square root, so I just multiply it times itself. So numerator, I have an x on the outside times square root of y on the inside. Then I have a y squared, and then square root of y times square root of y is going to be y. So I have x square root of y over y to the third power. All right, then for this last one here, this last example, you can see that we can reduce this fraction 5y squared over 25y so that it is, and this is a cube root, so that it is 5 over 25. It's going to give me a 5 in the denominator and a y in the numerator when I reduce that fraction. So then I need to rationalize the denominator because there's still a number in the denominator. So it is going to be multiplied. I'm going to change it to a 125. So I'm going to multiply this by 25 and 25. And that's going to give me then the cube root of 25y over 125. So my answer then is going to be the cube root of 25y and the cube root of 125, which is 5. All right, so try J and then pick up on the next video.